the underlying storage layer here, which allows us to give you low latency performance. So on queries, you see a single-digit millisecond latency, so between 0 to 9 milliseconds on queries, which is fairly interesting. Question there, Ben? Very good question. Yeah. So the question was if we could automatically adjust the throughput capacity based on timing or potentially load in Dynamo DB. So fairly good question. The answer is yes. There's actually an open source project that helps you doing that. Because DynamoDB is an API, so it's a web service, so you can easily adjust that throughput at any point in time. And there's a project called Dynamic DynamoDB, which measures the throughput. If you get to a point where you reach threshold, it automatically increases your throughput, and vice versa. If your load goes down, and it looks at CloudWatch to do that. CloudWatch is our monitoring service. The load goes down, it turns down the throughput and effectively makes you save cost. There's another one, I think it's called Auto Scaling DynamoDB or something like that. The best one I've seen is Dynamic DynamoDB, and a lot of our customers are using it actually for their production environment to automatically have it readjusted. And it's a very good point, because even though you can adjust it, unless you would scale it down, you don't save as much cost as you could. I'll give you my email later, I can send you the URL. Now, just looking a little bit further at what we could do, one last thing I just wanted to mention it. One important thing when it comes to a database is durability. You don't want to lose data, right? How do we do that? Replication. DynamoDB does that for you, so whatever you write inside here is automatically replicated across 3 facilities, 3 different data centers, before the write is acknowledged. So there's a quorum acknowledgement, meaning if it says you've written to DynamoDB, it already has been replicated across these other facilities. So even though if now an entire facility would burn down and go up in fire, you would still have your data available. So that's another interesting element here that you don't need to worry about that. It becomes a table, and I write to it, and that's it. I just want to give you an example for this. Shazam, I'm not sure if that's so popular. It's an Israel-based startup. Anybody knows Shazam here? Few? That's right. All right, it's a mobile application which allows you to kind of, if you hear a song in a bar somewhere, or a concert or whatever, you tap a button, it listens to the sound, it fingerprints the music, and it will then tell you the name of the song that somebody's playing. So I sometimes DJ in my free time on the weekends, and that's how I build up my playlist. I go everywhere to bars, and this is cool, and then I build up the tracks. All right, now you know my secret. But Shazam, just to give you an idea, they are a heavy user of DynamoDB to store the fingerprints of the songs. And it has become a really popular app. It generates about 500,000 writes every second onto the DynamoDB table when people start fingerprinting music, which is impressive. 500,000 writes every single second against DynamoDB. So for them, using something that is managed, where they don't need to worry about service, was fairly interesting. Another interesting element is Super Bowl is a big event, a baseball event in the US. And during Super Bowl, a lot of people are apparently using Shazam to kind of listen to what music, understand which music is currently being played. Shazam is using their own fingerprinting algorithm, and for that they use virtual servers in our platform. During the Super Bowl, they need 200 additional servers just to power that fingerprinting service and virtual service. Now, also to your question, when it comes to scaling things up and down, the same goes for servers, right? So that's a great thing, because the Super Bowl, after it's done, you just shut down all your servers. Think about the element of cloud computing, and don't just see it as a cheap place to get virtual servers. When it comes to data analytics, think about how can you make a yellow little elephant happy. You give him lots of nodes, right? You give him lots of servers so he can work in a distributed manner. Now, as a matter of fact, we charge per hour, right? So one instance for 100 hours is the same price than 100 instances for 1 hour. And if you think about a distributed model like Hadoop, it actually has fairly linear scalability in its performance. It's slightly sublinear, meaning that you get the same job done faster for the same price. If your current job needs 100 hours to complete and you only do it on one server, well, you could do it on 100 servers, same price, but do it within an hour. That's pretty powerful. And just one last thing here. It's not on the slides, but we get another interesting pricing model called spot pricing, which allows you to tell us how much you want to pay for a server. So even though we say this server costs 70 cents an hour, for example, you can say, I want to pay 1 cent for it. And we continuously have a market rate, which is based on supply and demand of the service. And that market rate, you find very often it's about 90% cheaper than the on-demand price. Now, if you set a bid price like this, and the actual market rate is below your bid price, you get that server for not only the price that you're bidding, but the actual market price that you have. So one really cool thing that you can do is, you set a bid price on the on-demand price, and you get the actual market rate much cheaper. If you translate this into this, you could say, I need to complete my job within 100 hours. But I could do it faster, so I could just do this. But in addition to that, I could take the other 99 instances in the spot model, which maybe just cost me a few cents now. So I get it done faster and even cheaper. And you'll find that our fully managed Hadoop service actually has integration into the spot pricing model, so that you can tap onto the actual market rate of service, which is much, much lower than the on-demand price. And that's something you're interested in, just contact me. I can explain that a little bit further on how you can do that. Pretty cool. I mentioned data warehouses earlier. Again, I still think SQL is a fairly important language, and even if you write your R programs, sometimes to just do a simple aggregation of the data before you load it in, fairly often you do it with SQL queries. Now you'll find that these SQL queries often aggregate data across columns. So what you find in a relational database like a MySQL or PostgreSQL is that all the information is stored in a row. If you would look on the disk drive, actually that row always sits next to each other. So if you now throw a query against a relational database where you say select, count of this column where field is like this, it needs to load up all that data, then remove all the columns it doesn't need, and then aggregate them, which is not fairly fast. This is where columnar storage can be used, and most data warehouses actually use columnar storage. So instead of storing rows, it's storing it in columns, and that makes it much faster for you to do aggregation queries. So great for analytics use cases. This is exactly what Amazon Redshift is doing too. It's a fully managed data warehouse of columnar storage. This fully scalable, our current upper limit would be 1.6 petabyte, right? 1.6 petabytes. So that's 1.6 times 1,024 terabytes. That's a lot of data that you can store in that data warehouse. And we manage a fully scalable cluster of data warehouse nodes. For you, the more important part is it has full NSI SQL compatibility by using ODBC or JDBC connectors. So you can write your SQL queries just the way you used to do it. With all the tools, if you have business intelligence tools, you can connect them to it. They can also load up data straight from Dynamo DB and S3. So again, going back to that use case earlier, store your log files in S3, then move them up to your data warehouse. Here you can now throw a query against it with SQL. In terms of cost, you'll find that comparing this to other commercial products, it's about 1/10 of the cost of what you see out there in the market. Fairly cost effective. And one of our biggest customers of Amazon Redshift is Amazon. And this is funny because you might think that's obvious, but we actually need to win the business of Amazon.com. We're different divisions of Amazon, and our retail business says, well, why should I use Amazon Web Services? Well, and then we need to make a case for it. And as a matter of fact, Amazon.com is using Redshift for their web log analysis. So the online retail business is doing that. What are they trying to do? They go through all their logs. Remember what Jeff Bezos says earlier? Customer experience is important. they tried to understand the customer behavior based on the click-throughs that they had on the log files. So things like who's browsing the website but not buying anything, which products are the winners, which products are fairly often looked at, which products are clicked at, what is the sequence that somebody had to go through products that actually led to a higher conversion rate. This is interesting. And you probably experienced this yourself when you did some e-commerce online shopping. Unless you have a very specific idea of what you want to buy, you start with the first product, and you look at it and you're like, okay, this is interesting. And then you go to the next product which is related to it. Then you start comparing it. Then you go back. Then you look at another product before you make your final buying decision. And that is very often around price, around functionality, etc. Understanding how those sequences lead to each other can help you improve the upsells or the possible recommendations that you give your users to further increase that conversion rate. So simple log files can help you do that. And again, just to give you a few metrics here, Amazon.com, just web logs generate about 2 terabytes of new data every single day. And the largest table in the data warehouse right now is about 400 terabytes large. Just one table, 400 terabytes. So with the queries, you'll find that we scan with Redshift about 2.25 trillion rows of that data in about 14 minutes, and we load about 5 billion rows of data, full table scans, within 10 minutes. Just to give you an idea of comparison, these are actual numbers from our online retail business. So they used to have a Hadoop platform to do this log transformation with Pig. Took them for the same amount of data about 2 days and 1 hour. And they then switched it to an Oracle database before actually running it with Redshift. The Oracle database, they had about 90 hours up to 8 hours depending on the complexity of the queries, compared to now 14 minutes. So that's the kind of improvement that you can see in terms of performance. Juicy, Amazon Machine Learning, was released last year at our San Francisco conference. So let's have a look at it. Amazon Machine Learning is actually a service that is fully managed for certain machine learning algorithms, and those are powered or based on Amazon's internal system, so the retail business. So we have certain algorithms that we developed, and you can tap onto those using Amazon's machine learning service.